Hi everyone. I wanted to do this worksheet along with you for today's video. Um, this is one that I posted last week, and I've been getting some questions and some concerns of people that don't quite understand. So instead of going through things on the overhead, I'm going to work some of these problems out and kind of explain this as I go. And as always, please ask me any questions, email, call, text, whatever you need to do to go through this. But this is the one that was called ID and Balance Quiz. So for this, the instruction said to balance and then to identify. So the first thing I want to do, because I think it's a little bit easier, is the identification of it. So for this first example, you have a compound, potassium hydroxide, and a compound, hydrogen chloride, potassium chloride, and water. So you have a compound, and you look on the notes, and things that involve all compounds was a double, either a displacement or replacement. It depends on the text as to how that would be. So for this one as well, compound, 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 and compound. So that is a double as well. Element, compound, element, compound, single. This is a compound, but it's breaking down. So you have one thing breaking down into two things. So that is decomposition, where it's decomposing because it's breaking down. So here you have compound element, single. Here you have two things coming together. Remember that sign means yields, coming together to form a compound. So that is a synthesis. This one was stumping some people, so I kind of wanted to go through this as well. A compound and element, even though it's a compound and a compound, because you have that single element, that makes it a single. Because in order for it to be a double, it has to be all compounds. And here it is not. It is a single. For this one, compound, double. Compound, element, compound. Because it has that single element, it has to be a single. Compound. These are all compounds. Those are all compounds. These are all compounds. Element, compound. Yields. So you have two things coming together to form one synthesis. Single, double, single. That is a single displacement. So now I'm going to switch over and we are going to balance and explain that. So to check your balances, you want to go through, count the atoms like what we were doing before we left. And here you have one potassium, one oxygen, one hydrogen, one chlorine, one potassium, one chlorine, two hydrogens, one oxygen. And remember, that is your line of separation. So I use fingers to compare and go back and forth. Oops, I moved the paper. Let me see if I'm still centered. Yeah. So I have one potassium, I'm good. One oxygen, I'm good. One hydrogen plus, there's another hydrogen here, gives me two. 1 chlorine, 1 chlorine. That is balanced. If you want to pause the video and practice through any of these at any point, please feel free. I am going to go over all of these with you. Instead of starting new instruction, which we actually need to. We're covering acids and bases and nuclear chemistry. But I know you have the quizzes, and I know you've got a lot of assignments, and some of you have been working really hard. So let's do number 2. 3 calciums, because the coefficient of 3 goes to that. This 2 distributes to here. So I have 2 oxygens times that gives me 6. 2 hydrogens times the 3 gives me 6. 2 aluminums, 3 sulfurs, 12 oxygens. On this right side, I have 3 calciums, 3 sulfurs, because that distributes. And then this distributes as well. 3 times 4 gives me 12. Now I have 2 aluminums. 3 oxygens times 2 gives me 6 oxygens as well as 6 hydrogens. So now let's count. I have 3 calciums, 3 calciums. I'm good. 6 oxygens. Don't forget to add the 12 from over here. So 6 and 12 gives me 18 oxygens. Over here I have 12 oxygens and 6 oxygens. Aluminums, 2 and 2. 3 sulfurs, 3 sulfurs. Balanced. The other way to do this, which if you're dealing with polyatomics and they're all the same on both sides, is to just count the number of polyatomics. So this would have been 6 hydroxides if you were doing it that way. 3 sulfates. 3 sulfates, 2 times 3 is 6 hydroxides. You could do it that way as well. So that one is balanced. Moving on. 3 magnesiums, 2 irons, 1 iron. Got a problem there. 3 oxygens, 3 oxygens. Okay, my irons are off. So now I got to go back and fix this. So I have 2 irons here, so I got to put a 2 here to give me 2 irons, and that's it. So always recount. 3 magnesiums, 3 magnesiums. And remember, yields is your divider line. So if putting something helps you, then fine. 3, 2 and 2. 3 oxygens, you're good. Let's count this. 2 leads distribute 2 sulfurs. 2 times 4 is 8 oxygens. 2 lead, 2 sulfurs, 6 oxygens, and 2 oxygens over here. So again, this is your divider. 2 leads, 2 leads. 2 sulfurs, 2 sulfurs. 8 oxygens, 6 plus 2 is 8. Balanced. I'm just checking the video to make sure. Yeah. Number 5, in counting that, 1 nitrogen, 2 nitrogens. There's my divider, my yields. 3 hydrogens, 2 hydrogens, 2 iodines, 6 iodines. This is way off, but we're going to fix it. Okay, so if I have 2 nitrogens and 1 nitrogen here, I need to add a 2 coefficient. That in turn will change my nitrogens to 2, change my hydrogens to 6. I have 2 hydrogens here, so if I add a 3 to that, That changes that to 6. I should have written that in the other color since that's what I was doing. 2 iodines, 6 iodines, 3. 3 times 2 now makes this a 6. Go back through and double check everything. 2 nitrogens, 2 nitrogens, 6 hydrogens, 6 hydrogens, 6 iodines, 6 iodines. So the coefficients you would need for this would be the 2, the 3, and the 3. Moving on to number 6. We have 2 and 2, 1 oxygen, 1 sulfur, 3 oxygens, 1 and 4. Now that you've got that counted, my hydrogens are equal. I have 1 oxygen plus 3 oxygens gives me 4, which is over here. 1 sulfur, 1 sulfur. Balance. Number 7 is a very tough one, so I'm going to wait on that. Number 8. Let's count. 1 and 1, 2, 3. 3 times 3 gives me 9. 1 and 3, 2, 1, 3. If you can count, you can balance equations. Okay, all balanced. So, I have 1 silver and 2 silvers, 1 iodine and 3 iodines, 2 irons, 1 iron, 3 carbonates. I'm gonna do this as a whole carbonate. Since I have a whole carbonate over here, just keep it easy. So 3 carbonates. I need to make this a 3. If possible, always start with your polyatomics, since those are the usually more difficult to do. So now I have 3 carbonates and I have 6 silvers, because 3 times 2 is 6. Come back over here to silver, add a 6. That now gives me 6 silvers. Distribute 6 iodines. I have a 3 here. So if I add a 2, that makes me now have 6 iodines, 2 irons, 2 irons. Ding! Balance. Number 9. Don't have any polyatomics that are the same, so I have to do this breaking down by metal, by elements. I have 1, I have 4, 2, 1, 2, 2, 1. My hydrogens are not balanced, so put a 2 in front of there. That now gives me 4 hydrogens and 2 oxygens. So now my hydrogens are balanced. They're good. Carbons are balanced. They're good. I have 2 oxygens. Over here I have 2 oxygens plus 2 oxygens gives me 4. So if I add a 2 to there, that gives me 4. Okay? And in double checking and counting these next ones, I have 2, 5, 5, 5, 5, 5, 2, 5. 2 and 2, 5 and 5, 5, 5, 5, 5. Balanced. Notice with this, my polyatomics are equal, so don't stress about having to break those down. 1 manganese, 2, 1, 2, 1, 2, 1, 2. 1, 1, 2 and 2. Berylliums are equal. Chlorines are equal. Cha-ching. 12. 1, 1, 1. Keep your polyatomic together. Make it 1, 3. Polyatomic, there's one of those. 1, 3. 3 silvers, 1 silver. That now gives me 3 silvers and 3 bromines. So now let's start over our counting. 3 silvers, 3 silvers, 3 bromines, 3 bromines. 1 gallium, 1 gallium, 1 phosphate, 1 phosphate. That balanced it. 13. For this, you can count your sulfates, but it's going to be difficult because this hydroxide breaks down into single elements. So, count the individual elements. There are 6 hydrogens, 3 sulfurs, 12 oxygens, 2 borons, 2 oxygens, 6 oxygens and 6 hydrogens. You have to distribute the 3 subscript goes into the parentheses, multiply that by the coefficient. That does not affect the boron because boron is outside of the parentheses. Counting here, I have 2 borons, 3 sulfurs, 12 oxygens, 6 hydrogens, 3 oxygens. Counting is done. Now, let's use our fingers and compare. 6 hydrogens, 6 hydrogens. We're good. 3 sulfurs, 3 sulfurs. Yay! 12 oxygens plus 6 oxygens gives me 18. 12 plus 3 gives me 3. We messed up. 2 borons, 6 oxygens. Hydrogens, there were 6. Hydrogens, there were 6. So for this one, you're going to have to change one of the numbers. And that number you would change is this one. And you would make that a 6. Because now that gives you 12 hydrogens. 6 hydrogens plus 6 hydrogen is 12. And the 6 plus 12 is 18. So that makes this balanced. Last 2, we're almost done. 8 sulfurs, 16 oxygens, 8 sulfurs, 16 oxygens. Well, that was easy. Count the last one. 1 iron, 1 iron. 2 silvers, 2 silvers. Keep your polyatomic together. 2 nitrates, distribute 2 nitrates. That is balanced as well. So, there are other sheets to do. I want to ask you to please continue working on this. Let me know if you need help or if you need me to post another video of some of the other work and going through it. Tomorrow I will post the new material on acids and bases and nuclear chemistry. Continue to keep up with your quizzes. I know you've got a lot to do, but communicate with me. If you're not able to access something, thank you to those that could not view the videos, and hopefully that has been rectified. If you prefer paper copies, you must let me know so I can gather it. The office hours of the school has changed from 10 to 2 only. So that's going to limit the time that I have with you in the room. So I hope this helped. I'm going to draw a little smiley face. Hopefully your day is going shiny and bright. Have a great day. Please stay safe. Bye.